Okay, so an intercepted arc is an arc associated with and determined by angles of the circle. An intercepted arc, and this word always reminds me of football for some reason, intercepted, like an interception. So maybe if thinking about it in those terms might help you, go ahead and use that. An intercepted arc is a portion of the circumference of the circle located on the interior of the angle, whose endpoints lie on the sides of an angle. And that sounds kind of far up, right? Let's go ahead and draw an inscribed angle first, and then we can kind of see what we're talking about here. So we're going to go to our pictures. There we go. And we're going to go ahead and draw an inscribed angle. Remember, an inscribed angle has its vertex on... Ooh, let me make sure that my ruler is working. So an inscribed angle is an angle that has its vertex on the circle, like so. And we're going to move it over here. Like so. Okay, doesn't need to be perfect. And we're going to name it angle PSR. So S is in between P and R. So that means that your S is the vertex. Okay, and there we have it. Make sure you click done and done. Make sure you upload that picture. So now let's talk about the intercepted arc associated with this angle. So the intercepted arc in this picture, and an interception in football is when the other team, the opposing team, gets the ball. Or takes away the ball from the other team. So let's think of interception like taking away. And so if we think of interception as taken away, this part of the arc of the circle, or the circumference of the circle, has been taken away from the entire circle. So that is the intercepted arc, the one that I've highlighted. And we can call this intercepted arc, arc PR. So that'd be arc PR. Okay, so here consider the central angle. And it says to use a straight edge or a ruler to draw an inscribed angle that contains point A and B on its sides, and name the vertex of your angle point P. So remember, what we are shown is a central angle. They're asking us to draw an inscribed angle. An inscribed angle is what we just drew. So they want us to draw the same type of angle, but now on this picture. So make sure you take a screenshot of that. We're going to go ahead and use our ruler again. And this time it's got to go through points A and B. So I've got to make sure that, let me make sure that's a little better. There we go. And we're going to move it like so. And I believe it says to name the vertex point P. And we're going to click done and done. Okay, and we can go ahead and upload that. What do the angles have in common? So if we go back to our picture and we're looking at both of those, what do you think they have in common? So I'll give you a moment to think through that. Maybe pause the video. So if you can tell, they are both intercepting the same arc. They both are intercepting arc AB. So you can go ahead and type something around those lines. Now they want us to use a straight edge to draw a different inscribed angle that contains points A and B as well on its sides, but this time we're going to name its vertex point Q. And since at this point you should have already uploaded this picture, I'm going to go ahead and just draw it on top of the picture that I already had. It might help with comparison, for comparison reasons. So let's see. I'm going to draw it like so, perhaps. Gonna make it green. It's got to go through points A and B. But it's going to have a different vertex. Oops. Gotta draw that red line again. Let's go ahead and do that. And there we have it. And I think they told us to name this Q. And done, and done. And go ahead and upload that. Now, how is the measure of the inscribed angle related to the measure of the central angle and the measure of arc AB? So once again, how is the measure of the inscribed angle related to the measure of the central angle and the measure of arc AB? Take a moment to pause and see what you think. Maybe discuss with somebody. Well, if you can tell the same thing here, the measure of this new inscribed angle is the same as the red one. They intercept the same inscribed arc. Okay. All right. Let's go ahead and draw one more inscribed angle that contains points A and B on its sides and name its vertex R. So we're going to do this one more time, just to make sure you guys really understand this concept. I'm going to go ahead and draw it over here. What you guys should be noticing is that, let's make it a different color. Let's make it purple. What you guys should be seeing is that all of these inscribed angles are having the same, they're intercepting the same arc. And that's going to be very important in a few minutes. I believe they told me to name it R, and the vertex R. Yep. Very good. I'm going to click done. And I just want to highlight here to help us see that they're all intercepting the same arc AB. Okay, how is the measure of this new inscribed angle related to the measure of the central angle and the measure of AB? Again, same question. How are these related? And if you guys have already noticed, it's the same thing. They all intercept the same arc. So what do you think we can conclude about the inscribed angles that have the same intercepted arc? If they all intercept the same arc, what do you think we know about all of these angles? If you said that they are equal, you are correct. So basically, if the inscribed angles are intercepting the same arc, they're going to have the same measurement. All right, last one here. I'm not sure how to say this name, but Dalia says that the measure of an inscribed angle is half the measure of the central angle that intercepts the same arc. Nate says that it is twice the measure. Sandy says that the inscribed angle is the same measure. Who do you think is correct? So pause the video and just kind of let that sink in for a few minutes and see if you can figure out who is the one that is correct. If you said that Dalia is correct, you're right. From the previous questions, we found that the inscribed angle is half of the measure of the central angle. All right, good job. See you in the next video.